Hello, ladies and gentlemen. Welcome back to part 2 of chapter 3.2. Here we're going to talk about residual plots. Okay, we just got done talking about residuals. Now we're going to look at residual plots. We're going to look at the R squared on the calculator, which is the coefficient of determination. And we're going to look at an alternative way to find the least squares regression line. And then there will be another video that's going over another example of most of what I have gone through in this lesson, and if you need another example to look at. Again, I can't stress enough, make sure you look at the examples in your book. As you're taking notes, rewind, pause if you need to, watch it again, okay? It's amazing the power that you have. If there's something you didn't quite get, you can rewatch it. And don't forget, Khan Academy. You all have Khan Academy accounts. If you need to, go to Khan Academy and look at some of the same stuff. All right, let's get started here. So this video hopefully will not be as long as the last one. So we ended with finding the residuals of the data points. Remember, the residual is the distance from the observed to the predicted. It's that vertical distance. And if that line is going through the center like it should be, the residual should always add up to 0. But now we're going to look at residual plots because they also tell us something. Just because we have the residuals doesn't mean that maybe this least squares regression line is the best fit. All right, so what we're going to do is we are going to look at some good and bad residual plots and take a moment and draw these down. Okay, good residual plot versus bad residual plot. So again, you may need to pause, maybe rewind if I'm going too fast. All right, so let's go ahead and take a look. Now, this is a residual plot, and I'll show you how to do these with the calculator in a little bit. This is a good residual plot. Notice how it's evenly scattered above and below the line. Okay, it's going to be a horizontal line. Okay, this is a good one. Dots are scattered evenly above and below, and we see no pattern. Again, let me repeat, we don't see a pattern here at all. So this is good. This means making a prediction with the least squares regression line is reliable. So that is a good residual plot. Okay, moving on. This is a bad residual plot. And the main reason is because we see a pattern. Okay, well, that's telling me it's not linear, first of all. Obviously, it's curving. So a least squares regression line is not going to be good for predicting. No predicting here because it will not be reliable. We could predict, but the outcome, we can't trust it. Okay, so that is a bad residual plot. Here's one where it's not the best residual plot. Okay, it's going, well, it's scattered above and below, but look at what's happening here. It's flaring like this. Okay, so it's not the best. So this right here, this would be okay for predicting. If we were going to predict with the data from like here to here, that would be good. But then here it would be bad because it's more spread out. So making a prediction there cannot be reliable. Okay, predictions would not be very reliable. Sorry, my handwriting is so sloppy. All right, so the predictions there would not be reliable. It's not the best, but it's not the worst. Okay, that second one was really bad. All right, so what we're going to do now, ladies and gentlemen, if you need to pause, please. Okay, rewind. What we're going to do now is I'm going to show you how to do the residual plot on the calculator. Now, I've already done it, but I'm going to take you through the steps. All right, so this is the residual plot of that last problem we did with the hot cereal sales and the temperature, okay? So that last example we did in the previous, this is the residual plot for that. So this is how we do it. We change the scatter plot to list number 3. We're going to do zoom 9. That is your residual plot, okay? Here we go. So if you need to pause, pause, and then start it again. So what I did was, again, I still have all my data in my calculator, okay? I still have my residuals in list number 3, okay? It's important that you have those in list number 3. Then I went second y equals, I'm going to go to my scatter plot, my plot, and I'm going to go down, keep the scatter plot, and I'm going to go down to the y list, and I'm going to change that to list number 3. So I'm going to plot the residuals against the explanatory variable, and then zoom 9. Okay, just a second. Let me do quit. Zoom 9, and there's my residual plot. So I just took that. Now, when you draw a residual plot, you should draw your y-axis, your x-axis, and then just sketch it the best you can. You don't have to put numbers on it. Sketch the residual plot as best as you can. Now, this residual plot is not bad. Okay, this is a pretty good residual plot. Okay, so it's fairly reliable for making predictions to a certain point. Okay, remember there is a cutoff here. So if you recall, let me back up. If you recall, once we get to a certain range, making a prediction is not realistic, right? Remember, that's called extrapolation. Okay, so this is a good residual plot, but it's only good to a certain point. All right, I think I went too far. There we go. But that is a good residual plot. Okay, so that's how we do residual plots. And what does it tell us? Okay, it tells us whether the LSRL is good for predicting or not. If there's no pattern there and it's a good residual plot, we can rely on that least squares regression line to make predictions, unless there's a pattern. Okay, if it's a bad residual plot, then we cannot rely on it very well. Okay, so we can't just look at R, the R value. Remember, the correlation could say it's very strong, but if we have a residual plot that shows a pattern, that's not a good thing. Okay, now how about that R squared, Mr. Ellering? Okay, I mentioned the R squared, so remember, okay, I'm going to go ahead and do my stat calculate, number 8 again, and if you recall, list 1, list 2, if you recall, there's an R squared there. Okay, that again is called the coefficient of determination. Coefficient of determination. What is it? The proportion of variation in the values of y that explained the least squares regression line of y on x. Okay, I'm going to start off. Actually, I'm not going to talk about the problem we're looking at here. I'm going to make up a problem. So I'm going to go down a little ways. Okay. Let's say, for example, so I'm not going to do the temperature one here. Let's say, for example, I've got a situation here, ladies and gentlemen, where we're selling a house. Okay. We're selling a house. So, and a lot of the price is based on the square feet of the house, right? How big the house is. Okay, and then I'll put price on the side. So that's a positive, obviously. So you could look at the square footage of a home and you could see that, you know, it's going to, as the square footage goes up, the price goes up. They're not exactly going to be all the same price, so it's going to be a scatter plot like this, right? Okay, and then we found that line that goes through the center, and we found, you know, we found the A, we found the B, then is the R squared, and then the R. So the R squared is what we're interested in. And let's imagine, again, I don't have data for you, but I just want you to get the concept of this. Let's say that the R squared here was 0.81. okay? 0.81. And then the R would say 0.9. Well, think about this. 0.9 squared is 0.81. The correlation squared is the coefficient of determination. So if they don't give you the R squared, but you know R, you can figure it out by squaring it. Okay, so this is our coefficient of determination. So what is it telling us? Okay, so let's think about this. Remember, everything is approximate here. So we could say about 81% of the variation in price, that's the y-axis, among, whoops, let me spell that a little bit better. Among the individual homes is due, and yes, you got to write sentences. So practice, is due, that's why look at those examples in the book, is due to the straight line relationship between price, which is your Y, and square footage, which is your X, of the homes. Whoa, really, Mr. Ellering? Yeah, there is a shorter way you could write this, maybe a little bit shorter, but again, details. You got to put it in context of the problem. Okay, so in other words, okay, i.e., now let me do that a little bit better. In other words, ladies and gentlemen, now this, what I'm writing now is not AP appropriate. What I wrote in purple is AP appropriate. What I'm writing now is not. So in other words, folks, 81% of the price is based on the size of the home. %81 of the price is based on the size of the home. The other 19% could be updated bathrooms, updated kitchens, hardwood floors, etc. Okay, but what this is saying is 81% of the price is based on the size of the home. All right, so hopefully that makes sense in this scenario. So square footage of a house, price, coefficient of determination is 0.81, which is 81%. 81% of the variation in price among the individual homes is due to the straight line relationship between price and square footage of the home. In other words, 81% of the price is based on the size of the home. Okay, now looking at our problem, ladies and gentlemen, the temperature. Well, here it says R squared is, I'm going to round it to 0.94. All right, so R squared equals 0.94. So we say about 94% of the variation in cereal sales, which is your Y, is due to the straight line relationship between temperature, nope, let's back that up, between hot cereal sales, between hot cereal sales and temperature. In other words, okay, again, this is not AP appropriate. In other words, 94% of the hot cereal sold is, whoops, that's not the word is explained by temperature. Okay, the other 6%, I don't know. Okay, those are factors we don't know. The one factor we do know that contributes to hot cereal sales is the temperature. So 94% of the hot cereal sales is explained by the temperature. Okay, again, that is not really AP appropriate if they ask you about R squared. All right, again, pause, rewind if you need to, ladies and gentlemen. I'm going to keep right on rolling here. Now, there's an alternative way to find the equation for the least squares regression line. And yes, you need to know this. I haven't gone over the formula sheet with you yet, and I will be doing that soon, okay? Probably in the next chapter or the chapter after that. So there's a few things on the formula sheet you definitely need to know. And this is on that formula sheet. So what we're going to do here, ladies and gentlemen, is we're going to be given some information, okay? We're not going to be given all of the data. We're going to be given pieces of it. So this right here, ladies and gentlemen, is a formula to find the slope, okay? B equals R. R is the correlation times S sub Y over S sub X. Well, S sub Y is the standard deviation of Y, and S sub X is the standard deviation of X. Remember, X is your explanatory, Y is your response. Now, here, this is the mean of X and Y. So the mean of all of the X values and the mean of all of the Y values. And what we're going to do, ladies and gentlemen, is we're going to use this right here to help find A and then be able to write an equation, okay? A prediction equation. So here we go. So I've got some information right here. So step number one, I am going to go ahead and I am going to find the slope. So B equals the R times the S sub Y, 1.2, divided by the 0.6. So that's going to be my slope, ladies and gentlemen. And I already did the math for this. Hopefully I didn't do it wrong. I get 1.6. So that's my slope. Okay, now, in order to find A, I'm going to have to plug in the numbers that I know here. So I know the mean of Y. Again, they have to give this to you. The mean of Y is 5. I don't know A, that's what I'm going to find, plus B, I just found it, 1.6, and then the mean of X is 4. So I'm going to find my y-intercept is what I'm finding here, ladies and gentlemen. Okay, my A. All right, I'm going to do my algebra, and I already did that to save some time. Hopefully I didn't mess up. Okay, and I get A is negative 1.4. So now I can write my y hat. My y hat equals negative 1.4 plus 1.6x. So I was able to use that information to be able to write my prediction equation, my least squares regression line for that situation. Okay, I'm only doing one example of that, so if you ever need to, go back and rewatch that. See how it's going to be on your test. It's guaranteed it's on your free response test. Okay, all right, so other things that you need to know. Okay, here's some output. Whoa. Okay, well, let me go through a few things here. So first of all, here's my R squared, ladies and gentlemen. Okay, there's my R squared. My R squared equals 99.1%. So as a decimal, that's 0.991. Okay, notice, ladies and gentlemen, it does not tell me r. But I could figure out r by taking the square root of that. And then I'll know my r. So just FYI, they might not give you r, but they might give you r squared. But if you have to find the correlation, you got to take the square root of that. Okay, what else do they tell us? Well, right here, they give us some information. Okay, the regression, sum of the squares is 168.581. The residual, 1.60821. Okay, that doesn't tell us too much. This DF is degrees of freedom. I'm going to teach you that stuff later. The mean of the square and the F ratio, we don't need to worry about those now. So really, this, what I just circled in blue, okay, we don't need to worry about. But down here, this is where we can write our equation. You just have to understand what is what, okay? So here we go, ladies and gentlemen. This constant, that is your A. That is your y-intercept, everyone. I'm going to round that to 1.09 plus this right here, ladies and gentlemen, that second one, that is your B. That is your slope. That is your rate of change. I'm going to round that to 0.19x. So this information right here in the table, variable, constant degree, coefficient, that tells us our equation. Now, just FYI, sometimes you can use words, ladies and gentlemen. Okay, sometimes you can use words. So instead of X, you could use degree days, okay? And instead of Y, you would put whatever it is, I forget what, oh, gas used. So this could be gas used. I'm getting that from right here, folks. That's your dependent variable. Remember, your dependent variable is Y. So gas used equals 1.09 plus 0.19 degree days. So instead of using the variables, when you use X and Y, though, remember you're supposed to define it. One way to get around that is to just put the words in instead of the letters. But if you use X and Y, you got to make sure you define. All right, so that's using a table. You have to be able to read and use a table. Read the examples in the book. Can't stress that enough. All right, so again, this is just what I showed you. This is in your book. And again, here's our slope formula, and then it passes through. That line should always pass through X bar and Y bar, which is the mean of X and the mean of Y. All right, and I think that's the same thing. That's it, ladies and gentlemen. Good. This video is quite a bit shorter. Again, rewatch it if you need to, rewind it. I will go over this in the next video. So I'm going to do this as an extra example if you need to watch me go through another example. All right, that will be right underneath this video. All right, folks, good luck. We'll see you soon.